One of the things about the fundamental theorem of calculus that we want to be aware of is that because it is such a keystone piece of calculus, we're going to get really, really good at it. We're going to look at a lot of different examples using the fundamental theorem of calculus. In particular, all of the examples that we saw when taking antiderivatives, we can now do definite integrals with those same functions. Let's take a look at example 2. We want to integrate 6 minus x squared with respect to x from 0 to 2. That can also be stated, find the signed area of 6 minus x squared between x values of 0 and 2. The first step is to find the antiderivative of 6 minus x squared, or at least an antiderivative of 6 minus x squared. We saw that earlier, 6x minus 1/3 times x to the third plus any constant. We'll utilize 0 as our constant as usual. And we've integrated from 0 to 2. So that means I'm going to plug in 2 into that function, 6 times 2 minus 1/3 times 2 cubed, and then plug in 0 into that function, 6 times 0 minus 1/3 times 0 to the third. Excuse me, I miswrote that. Now I can multiply this out and get an answer. You can do this on one line in one step, or you can do it in 2 steps where you find this number and then subtract this number, or you can just do it all in one step if you'd like. When I calculated that, I ended up getting a final answer of 9 1/3, which is approximately 9.33. You'll usually in Moodle, you will have to round your answer to a couple of decimal places. So 9.33 would be appropriate. If it asks you for the mixed number, obviously write 9 1/3. If it asks you for the improper fraction, that would be 28/3. I believe, though, in Moodle, it's going to ask you for rounded to 2 decimal places most of the time. Now we've calculated this definite integral. We found out that the signed area is 9 1/3. And that is exactly what the fundamental theorem of calculus tells us. Let's do another example. Find the definite integral using the fundamental theorem of calculus. We're going to integrate sine of x from 0 to pi. I believe I've mentioned this before, but I will restate this. Anytime we're dealing with trig functions and we're graphing trig functions, we'll be wanting to use radians. So make sure your calculator is in radian mode if we're dealing with trig functions. The vast majority of times in here. So unless otherwise stated, imagine we're in radians. Now, the antiderivative of sine of x, or at least one of the, is negative cosine of x plus any constant that we want. Obviously, I'm going to once again choose a constant of 0 because that makes my life a little bit easier. We are integrating from 1 to pi, or excuse me, not from 1 to pi, from 0 to pi. This looks a little bit awkward on my typing in, but hopefully that makes sense, from 0 to pi. We're going to begin by plugging in pi. So we get negative cosine of pi, and then subtract what we get by plugging in 0, cosine of 0. I'm sorry, negative cosine of 0. My apologies. Those negative signs are important, obviously. If you do negative cosine of pi, what you'll get is a positive 1. It's basically negative of negative 1. Cosine of 0 is 1, so we're going to subtract, and this here is a negative, so we're going to subtract a negative 1. Again, negative cosine of 0. Cosine of 0 is 1, so negative cosine of 0 is negative 1. That means the area under the curve of cosine from 0 to pi is actually 2. That is the integer 2. That should be a pretty surprising result in this instance. Thinking about how sine is this kind of weird shaped curve that goes up and down, and then we find the area, the signed area of the curve, and we get this nice integer number. That's a very, very interesting thing. So the area under this weird rolling curve, let me actually do this. From 0 to pi, that shape has a signed area of 2. Nice integer number of 2. And that's pretty surprising, that this weird shaped curve that goes from 0 to pi, pi is this irrational number. We don't have nice straight lines, but all of a sudden we get that area is just 2. Again, very surprising in some sense. Now that we've seen a couple of examples, I want you to try a couple of examples on your own. Push pause on the video, and in the next video, I will show you how to do these 2 examples.